Okay, it looks like we're live. So welcome back. Today I'm going to be going back to an older project. I haven't worked on it in a bit of time, a couple of months now. 3 months I guess. So Tim, that's what it's called. It is a virtual machine essentially. So similar to like Java virtual machine, that kind of thing. So basically we have an assembly, right? Which I can show an example of it. We have some of these. Let's look at Fibonacci, right? That's the wrong one. Right here. So some of the stuff I'm going to be changing. But basically, we have a preprocessor, so we can import a file, and then we can also define constants, right? This is for pushing strings. That's something I'm going to change. It's going to work differently. Then we push the value, and it's an assembly, right? That is how it works. And yeah, so it gets assembled to the virtual machine bytecode, which looks like this. So let's look at I think we can do this. Yeah, so this is what the bytecode looks like. Yeah, so it doesn't look like much because it's not human readable, right? But we have the code base is a bit of a mess. I have improved quite a bit since the last time I have worked on this. So let's see. We have let's not see. I think that's where it is. No, it's actually sorry. There's two different things here. There's the assembler and then also the virtual machine itself. So it's actually tin.c. Hey, what's up? How you doing? This is a bit messy because of things. All right. Let's see. So we have this is the interpreter essentially. So it's just a big switch statement. Yeah. So this is an older project, and a lot of the code is not super great. So I'm just gonna be sort of cleaning up today because I don't have a lot of time. Yeah, but that is sort of the goal. So I want to get back to working on this because I've been working on Kano, right? That is my text editor, which I'm actually using right now. I've been working on the scripting language for it. But I thought, why not just build it on top of this virtual machine bytecode? Because I think that makes sense. Because I've been planning on making a language for it for quite some time. So I want to get the virtual machine itself up to a decent point. Like it's pretty close, but there's a few things I need to add, and then build a language on top of it and use that, integrate it into Kano for Kano script, right? That is sort of the idea. Yeah, and I think it could be fun. I do want to update. Let's see, right here, just the c.syntax, so that we can include like this, so that it actually highlights properly. So let's try that. So we need let's see, int64t, and we'll do int32t as well. uint uint 8t, I think as well. I'm gonna use just ones I'm gonna use, not super worried about it. And uint 32t. So if I that right, and then reload it, it don't work. Why not? Should have worked. Actually, maybe we can't place these. And will it? Let me see. I'm not sure. No? What is wrong here? Not sure what the issue is. Give me a moment. Let's see. How about, what if I just put a random word in there? Alright, then it does highlight that. So that's not what the issue is. Shoot, it's because int is before that, isn't it? So that takes priority, right? Let me try moving this just up here. Using them for this, that's kind of funny. Let's see, how does that work? Nope. I'm not sure. Yeah, because the size type works like that. So it's not the underscore actually. I'm not sure what it is. Why would it want to load that? Yeah, because I added num here, and you can see that highlights. That is the color. The colors are a bit messed up. I'm using Tmux. Yeah. I'm not familiar with how to use it, but I learned a few keybinds and stuff. But I don't know. I guess the colors are different, so I need to figure that out. Yeah, but I don't know why this doesn't work. Oh shoot, it's because we can't have numbers. That's why. Yeah, okay, so that's just it's gonna look bad. Alright, I forgot that played that. So I need to actually update the Lexer. I'll do that later. It's not a big deal, it's just looks kind of weird. Okay, so let's see. I need to refamiliar myself because I've not looked at it, as I said, for 3 months. So, let's see. Yeah, let's look at this first. We have a couple things here. These are just some, these are the, like, built-in functions which we import, into the bytecode, essentially. And we can interpret it from there. So that's gonna be useful when we're integrating it with Kano, because we'll be able to write C functions that can actually be called, and that would be pretty cool. Get streams, that is like, yeah. Open mode, so yeah, this is open stuff. Yes, these are the native functions actually, so like, for like reading files and such. Interacting with operating system, because we can't do that without calling C code. Okay, what else? Quite a few of them actually. I didn't realize I missed one. Alright, so this is push. This is like pushing onto the word, which is the stack, right? So it's a virtual machine, a stack-based one. There is registers as well, but they're not really used. I might get rid of them. But yeah, so it pushes onto that. Okay, yeah. Push pointers. That is for specifically pushing pointers. That is. So why do we have to do it like that? Hang on. Why can't we just interpret it as a pointer here? I don't think we need this. I don't think so. But I'll have to look into it. So push start, this is gonna get removed as well. I'm gonna right now I have just a string stack, specifically for strings. But I'm gonna get rid of that and replace it with just a memory stack. So like sort of similar to the arena, basically, is how it's gonna work. And you're just gonna, it'll be a dynamic array, right? And you can just allocate memory to that. And then strings would be stored there, and we'll push a pointer onto the data stack, and that's where you can interact with it. Essentially is how it's gonna work. We have pop. I don't know why it's not next to push, but okay. Yes, that's fine. Oh shoot, I forgot to update stuff. My bad. I forgot to update the title. That is not what I'm working on. Hello, how you doing? Yeah, I'm actually working on a virtual machine today, not a text editor. That is my bad. I forgot to update stuff. I always forget that. Here, I will update all this stuff. Okay, there we go. I should be updating now. That's my bad. I apologize. So yeah, Tim is it is a virtual machine. So that's my bad. I forgot to update it before I started the stream because I was working on text editor last stream. That's why that's what it was. This is not right. Why is it doing this? The highlighting is not right. Okay. Yeah, it's something weird with Tmods. Okay. Yes, these are just different instructions that we have. Basically, is how those work. And I haven't worked on this for a few months, so I am refamiliarizing myself today. I don't have a lot of time, so I'm not going to get a lot done. Mostly just remembering what I'm working on. Text editor projects are cool. I'm working on one myself. How does the editor parse your syntax highlighting finally? No, no rejects. Basically, here I can actually show it. Here, let's make a new Tmods window actually. Okay, there we go. So, oops. There we go. So, okay, okay, so basically the way it works is we lex it, not with rejects, but instead we just, we read it, to a string, and then we iterate over the string. Let's see where it's at. Yeah, basically iterate over it. We get this, but basically, let's go to where the parsing is for the, where is it? Hang on. That's the syntax file. That's the wrong one, actually. Hang on. I need to remember where it's at. I've not worked on this one specifically for a bit of time. Yeah, so it's right here. Basically, we just have a string here, which 32 is probably not enough, but and then we just append to that while it meets any of the things. So basically, is this the right place? Yeah. And then there's different types based on. So there's no rejects. It's just like string based, right? And then we use string compares. Like this is keyword. That just checks if it's one of the built-in keywords. And then its type as well, it's the same thing. Otherwise, it's just set to the default type, which is just called word. Yeah, but this is basically the whole thing, the whole lexing system. And then based on that, we generate tokens, right? This works for any language. So it's works best on C-based languages, but basically, the way it works is you can write concrete files. So this is just a temporary syntax while I'm working on the scripting language for it. But basically, this is what a syntax file would look like. So you can make it for any language, but it works best with C-like language. So this is actually there. I can show it in Kano, which is the text editor. Yeah, so basically you can put K means keyword, right? And you can put the color values and then all of the keywords in here. And then T is for type. You can put the RGB color values. Then all the type that you want in there. And numbers don't actually work. So I was trying to get this working. But numbers, you can't add them there, so I need to update that. And then this is like the default one. So it's not like super extensive right now. In the future, probably will do some reject stuff. I need to learn how all that works. And make it more extensive. But for now, this is basically how it works. It's a little bit limited. But yeah. So you can, it reads this file, right? So you can put anything that you want in here. So I made one for OCaml, which is like a different looking language. So that's why I went with that one specifically. So here's like OCaml keywords, right? And then the types and other stuff. So like it can Lex that as well. Clever approach. Any advice on what to read to understand tokenize? I sort of, let's see. Basically what I did was look up, let's see, I don't remember because I learned it a bit of time ago. Basically, most of what I learned was just from messing around. But basically, tokenizer. So let's right. Just looked up lexing, how lexing works, whatever, and then read about it. Yeah, the Wikipedia page that was a bit helpful. Like reading through this stuff, and then I just tried to implement one, and you can see it's quite simple. And let's see, where'd it go? Yeah, right here. Okay. Yeah, like this is basically the whole extent of this one. Oh, well, that's for that specifically. But then there's also the lexing of the config file, so that works a bit differently as well. But yeah, this Wikipedia page, that was helpful when I was learning it, and then just sort of mess around until you figure it out, basically. Yeah, I don't remember any other specific sources. Something I haven't really read it. I've read through some of it, but I think interpreters, like, you've probably heard of this. It's quite popular. It has some good stuff in there too, and they go over lexing because it's building an interpreter, right? In both Java and C. So that's I can't say it's good because I haven't read the whole thing, but I've read some of it and it seems decent. So like those two things are probably the most helpful for me. Okay. Print stacks. That's just debugging. Yeah, this is checking the types. Okay. Okay, that is running to the file. Yeah, and so we iterate over and we write to the string stack. But again, I'm gonna change that so that it is going to be it's gonna work differently. I'm gonna have to select it. It'll be quicker than rejects for every language I want to include. That, yeah. I probably would have done something with rejects if I knew how to actually use it. But that's usually like I never learned rejects, so that's just sort of how I do that. And it's more like more extensive. It's sort of easier, but it's a bit more limiting, I suppose. Like, because rejects can get pretty specific, or it's not like you could get all that stuff, all the same benefits of rejects, but it gets more complicated. Okay. But yeah, that's just how I've always done it. Okay. Instruction. Okay. Yeah. And this is the actual interpreting of it. Okay. Uh-huh. Alright, so that's pretty much it for this. I don't remember exactly how all these work, but they're easy enough to figure out. And that's the whole thing. So let's look at the assembler. So we have a few stages of it. Let's look at the main one first. So this, yeah, okay, there's a lot of stuff here. Okay, yeah, so we sort of go through this. Alright. So we call lex, so that is from the lexer, so we'll go to that. And then we parse it. And then we create a machine. So I don't know why I did it like this. Okay, so I'll have to There's a lot of stuff I'm going to have to update here. I want to go through the whole thing first. So let's look at the Lexer now. That's the wrong one. Lexer not C. There we go. Okay, what is there? Alright, so this is not too large. I don't remember how this works. I think we use the header file. That's where all the keywords are defined. Okay, so yeah, we just open file. That's simple enough. Alright, here's actually all the keywords. Okay. Yeah, I do a similar approach here. It's not as good because I wrote it quite a while ago, and I've gotten a lot better. But yeah, but it's a similar thing where it's just a list of keywords basically. Okay, that's just for printing. That's an interesting way to do that. Built-in keywords. Let's see. What is this? Oh, okay, I see. Yeah, that's okay. I understand. I understand what's going on there. Yeah, the index corresponds to the type. Okay, check label type. So this is, yes, that's parsing the labels. That's fine. A lot of this stuff doesn't matter because I'm not going to be using the assembly too much. And that's what this is for. It's the assembly Lexer essentially, and was the assembler entirely. But this is the Lexer specifically. Okay. Yeah, so this does all that. It seems probably more complicated than it needs to be. Escape characters. Okay. Generate character. Okay, yeah, so that checks for escape character stuff. Okay. String. So I think there's a lot of repetition here, and they could probably be reused. I'll look into that. Yeah, and this is the main thing. Okay, makes sense to me. So let's go to the parser now, which is the next stage, right? Excuse me. Okay. Parse list. What is this? Oh, okay, so that's just appending to that. Why did I do it like that? Huh. Okay, yeah, I see. Handle, token, yeah, okay. Check labels. Alright. And then finally, let's see, actually, is there another stage? That's it. Alright, so we have the hash map, which is not mine, so I'll replace that with mine at some point. Okay, parser. H. Okay, tire.c. So what is, so that is the runtime. Whoops. Okay. Yeah, so it's not much. It basically just calls to this and then reads the program and then executes it. Makes sense. Okay. Alright. So I think that makes sense. So let me try to start on this. So I'm gonna replace the string stack, which is, it's right here. So we have quite a bit of stuff here. So let's see. Yeah, this is the string stack. So there's a max string size. It's not exactly ideal. So what I'm gonna do is replace it with one of these, right? So the highlight is not red. I'll fix that probably by next memory. And I'll make it a dynamic array. So actually, instead of this, I'll make it a memory array. That. And so that will be so we're gonna have a few things here. We need first of all the data, right? It's gonna be an array, and then we need the count, and then the capacity. So it'll be a dynamic array, right? So we'll allocate it, and then it'll grow continuously as necessary. Yeah, and I'm probably gonna make all these a dynamic array as well, like the stack and such, but we'll get to that later. That's not super important right now. So we have the return stack. That is for like calls and stuff, so we know where to go. We could have just stored it on the regular stack, but then you have to manage it and stuff, and it's not as safe. Okay, and these could be, yeah, these could be work the same as this. So I need to actually make some memory. There we go. Okay, program size. So that, yes, that's the size. Bool. Why does bool not highlight? It should highlight, but it doesn't. Okay, and these are the registers. Yeah. So the way the registers work, it's kind of funny actually. Basically, just an array of data, right? So we have a register, which is right here. So it has data and then the data type. So it's sort of like a mini stack. And we can have any amount of registers. So right now there's 16, but there could be any amount, right? So I think that's kind of cool. And this is just the instructions, which is yeah, it is a dynamic array as well. And this is just all the definitions. Okay, so I want to try to incorporate that. Let's see. Okay, so just still compile like that. Uh-huh. So let me go to t.c, and I want to implement this memory so that we have a way to write and read from it, right? So basically, I need to think about how the syntax would look. So let me make a let's see, test.cas file, right? So I don't remember exactly how it looks, but I have an example here. So I don't need that import, but it's like push 5, right? So let's say we're working with memory. Let's see. So would it just take the top of the stack, or how would that work exactly? Got something in my throat. So we could have like be write or maybe memory. Memory, whatever. So then the amount, or maybe the amount would be on the top of the stack in like absolute amounts, right? So we would allocate 5 bytes in this case, right? So it pops off the top of the stack, allocates that much in memory for whatever, and then we need a way to write to it, right? So this reserves it. So we could write to it with like write X number of bytes, or maybe I could even use the stack, right, to get its arguments. So you push the amount that you want to write. And then we also need the data that you're gonna. So I need to think about how it would work, because I'm not sure exactly. And we do have write. It is a macro for this, so I'll need to think about that. So maybe it couldn't be called write. I'll have to reconsider things. But we'll see. We need a way to write and then read from the memory, right? So it's sort of like forth, right? I can open up forth. The way, yeah, array, it's right here. So this is how memory works in forth. It's like, you define a variable, and then you allocate this many amount, right? So like that is the amount that you allocate, right? So the variable, yeah, that creates it. So you can access it. I might have to do something like that. Have like a list of variable names. Do I need that? Well, we could just use the stack, right? And then, yeah, you can write to it with this. So the exclamation point writes to it. And then this is, yeah, that's the position in it that you have to write. I see. Yeah, so it's going to work similar to that. I want to use actual words instead of symbols, right? But it's going to be a similar thing to that. So let's see. Well, so calling this memory, it'll pop off a stack and it'll allocate that amount. So I think we can do that. So let's see, we usually do like 8, right? And then, so you write to it. So you push that in the index, which you would want to write. So the data and then the index. So, right. So 8, 0. So we could write, say 10 there, or you could write a character. It's like when we're working with strings, it'll be characters. And then we'll have some sort of syntax to sort of do all of this, right? So you could do, probably would use push string, because that's already an instruction, but we'll just repurpose it. Push string, you know, hello world. And what that would do, it basically would push this whole thing. So it would push the size of the string, which is, oh, actually it's going to be 14, right? And then we'll call memory, right? So it will allocate that amount. And then it will push each index, right? So it's sort of going to expand out into this in a way. Yeah, and then push each individual character, and it would be on the stack. So it would be allocated like that, right? Like that. And then it'll push the pointer to the start of it onto the top of the data stack, you know? So then you could access it and work with it and stuff. So I think that would work. Something like that. So I'm going to actually save this so that I have reference. And I'll try to implement that. So we'll implement it first in terms of t.c, right? Make a... there we go. Make a new one. And let me just take a look at... I'm going to have it open so I can reference it, right? So where is it? That's not Tatsy. There we go. Yeah, so just for reference. Okay, so we're going to repurpose the push string. So that's going to be different. And we're getting a few new instructions. So those will actually be in tim.h, where all the instructions are. So we need, let's see. I'll put it near the push one. So maybe like for swap and do. So we have reference and dereference, so those are probably gonna be changed as well. But let's see. Inst memory, so we need that one. Inst write and inst read. So we need those, and it will have operand. So I think I have something that expand to that. Maybe not. Okay. Yeah, but so those are going to be the new instructions that we have right now. Let's go to here, and let's take a look. Yeah, so we need to add them to this, or it's going to not work. So if we try to compile it, not there. Try to build it. Yeah, so we need to handle all of those. So let's add them after the rewrap. Yeah, right here. Case inst. What was it? So inst memory. Case inst right. And this is gonna break a lot of stuff. Like the test and stuff, but that's okay. Case inst read, and that is the next one. Okay, so we need those. So what they're gonna do. So let's look at the example again. Okay. Let me rename this. So I know. So just example. There we go. So we push 8. So it's gonna pop off the stack the amount that it's gonna allocate. So we can do that, right? So it's gonna data equals pop. Let's see, we need to pop the stack. I need a reference because I don't remember exactly how it works. So A equals pop machine. Yeah, so pop and we pass the machine. I can use A, I guess, right? A. Okay. And then if A dot type does not equal int, it has to be an int type, then we'll just we'll print error expected int. So I'll make that better later. Okay, and then otherwise we can continue. And we need to allocate memory. So I'm gonna actually copy a macro into .h from Kano. Let's go to Kano. And let's see, it's in .h. Let's take a look at that. Create undo. So I don't know if I can copy it across instances. Oh, that's not what I want. No, it's a different one. Where is it? It might be in Dex actually. Dex.h. But I would like to copy. Yeah, DA append. This one right here. Because that's it's quite useful. I don't think it's gonna it's not gonna work across instances. So I'm gonna have to let's see, I'm gonna use Vim for it. The Vim I can use that I can copy it a bit better. Let's try that. We'll just copy that. And then we'll go here. Let's put it here, sure. And there we go. That didn't quite work. So actually I'm gonna use Vim for this as well. That's it. Okay. And actually I'll go down with the other macros because that probably makes sense. Put it right here. There we go. And there we go. So we have that macro, and that's gonna be useful useful to use, right? So we want to use DA append in inst, right? DA append, and what does it take again? I don't remember. DA append. So we take the pointer to it, and then the item. So we need to actually do that int numbers of time. So for times the I equals 0, while I is less than int of less than a dot as int dot plus, and we can actually cast it. It can't be negative. So let me just if a as a less than 0, then we need to print error again. Error. It's cannot. Well, actually, this is size cannot be negative. Okay, so we'll do that. And then we'll iterate over it. So we need to cast I to. Let's cast this to a size type. Okay. And we need to DA append that many times. So DA append. So we need the pointer to what we're appending to. So this is in the machine, and it is memory, right? And then we need to the item that we're gonna append, which is just gonna be 0 in this case. It's gonna append 0, so it'll be 0 initialized memory, right? Okay, let's see if this compiles. That's not where I need to go. There we go. Try to build it. And we get quite a few problems. So machine memory is a pointer. Actually, it might already be a pointer, so I don't know if I need that. Yeah. Let's see. Data start. Oh yeah, so I need to copy the macro as well. I forgot about that. So let's open another again, and I'll just put it in here. So I'll just define it up here. Okay, define. And what was it that we're defining? Data start capacity. Data start capacity, and we'll make it 16. That should be fine. So I exit out of that. Open up this one again, and we'll go back here. How does your editor handle copy paste? So I didn't want any dependency, so it doesn't work with the clipboard. But right now, basically it has a buffer, right? Which is just a dynamic array. So you can select text, and then you can copy it, and you can paste it. So it just sort of, it's just a string buffer, and then just paste it into the wherever your cursor's at. Basically, is how it works. And it, pushes stuff over and everything as if you were inserting it. But there's no there's no clipboard support or anything like that, like system clipboard. You can copy something to the clipboard and try to paste it, but it doesn't work right. Yeah, only within that. Yeah, I do want to expand it eventually, but I don't use it that often, like clipboard stuff. So that's why I haven't done it yet. But eventually, I would like to do that. Okay. Print error is wrong. All right. So did I forget something in print error? Let's see. I've got it down here. Message. So why does that fail? Data has nothing as in. Why is that? Let's see. Oops, that's the wrong one. H as is as in. Oh, but it's a word. It's not data. Okay, that's what the issue is. So yeah, I need to fix that. So how do I fix that actually? Hang on. Oh, you have to do dot word. Okay. I see. Dot word. Okay, so this actually needs this. That's why it wasn't working. Because print error is not. It's not like that. So it's not gonna work like that. Okay. Because it expands into more than one state. Okay, I'm gonna do that here as well. There we go. Save that, and now it should work. Okay, so assert. Yes, we don't have assert. So I think I can just use regular assert. Will that work? And just use this. So we do include that. So we did not save. Okay. Sometimes let's do not save. Right, we do include assert that, so I don't know what the issue is. I need to include it in here. Okay, so it doesn't. Oh, I did it wrong. Okay, that doesn't work. I remember having this issue before, so I do need that macro. So that's fine. I will just go here and I'll just copy it. So I have it in here. It's the same thing. We don't want the end wing though, so I'm going to get rid of it. And actually, I messed it up now. Let's try it again. Get right here. There we go. And we don't need end wing because that was specific to. Okay, now it compiles. Hopefully it works. I want to implement the rest before I actually try it. Alright, so let's go to the next instruction. Int memory, that was one that we did. That writes to the memory. Then, or that allocates memory, but now we need a way to write to it. So how did I set that up? So you push the index to write within the memory block, but how do you know which memory block it is? hang on. So let me look at this. How does this work? It's like, what if you have multiple of them? Oh, okay, because you pushed that one. So how are we gonna handle that without like an identifier for it? I suppose you're just gonna use the pointer at the top of the stack. So we do need to actually do that. I didn't do that. So we need to push the pointer to the start of the memory. So let's yeah, so the start is gonna be the current memory size. Yeah, so let's do that. Push pointer. Which I don't know what this means. Okay, we need the machine. And then also the pointer that we're gonna push. Right. So the pointer is gonna be to machine memory. Let's see, machine memory dot count. This needs to be dot data actually. Dot count minus a dot word dot active. So minus that, and I think that should push the start, if I am not mistaken. Let me make sure that's still compiled, so it's not. We need a to do that. Okay. And that should not be a pointer, so that's wrong. So passing argument to a push pointer. So it's expecting that. Okay. So what is the pointer here? So it's a data. What is right here? Pointer. Right. So it doesn't like that. But we can set it to that. So it's actually a word. Word as pointer. Well, I don't know if we can do that. Word as pointer equals this right here. Whoops. I'm not sure if this will work, but I'm gonna try it. And then just not push pointer, but just regular push. Push word, and we set word dot type equals pointer type. I don't remember what it's called. It might be type pointer. I'm not sure. And we just push that directly. I'm pretty sure that's how we should do it anyway. PRM is to push, so push expects that value and then the type. Okay, so we pass the type like that. Wait, the types that still might not exist. I'm not sure. Nothing as pointer. Okay, let's look at this as. Oh, it's as. Why would I? Okay, that's what the issue is. Let's do as pointer. Spell out the whole thing. Whoops. Okay, now it compiles. So that should be pushing the start. I don't really have a way to test it now, because we need to update the assembly first, but we'll get to that. Okay. So then write. That is going to write to the memory based on, so the top of the stack should be the pointer, I think. No, actually it'll be the third on the top of the stack. I think that makes more sense because then you'll push the other arguments. Yeah. Right. So we're gonna need to pop 3, right? So A equals, actually, let's see. So I'll name them accordingly. I'll just call them this for now. Pop machine. Word 2 equals pop machine, and word 3 equals pop machine. Okay, right. So that'll pop all the arguments. So this is gonna be the pointer. Let's go to the example again. So then the data is gonna be right on the top, and the index. I feel like the index should go here actually. Yeah, so we'll do the data is the second one. This one is the data. And then this is the index. Alright. So that's what we'll pop. Let's see. And then let's do if index type is not equal. Wait a second. This needs to be a data. Yeah, it's not a word, it's data. Because that has the type as well as the value. Next, the type does not equal type int. Then we will do the print error thing. Error type int. Okay. If data.type, actually that can be anything, so we don't need to worry about that. And if pointer dot type does not equal, so that needs to be, that's gonna be an index, right? So just have to go type pointer type, actually, that's what I mean. I feel like pointer type is not the right thing, though. I just think it might not be. This needs to be int type, right? That's what the issue is. Type, there we go. Not equal pointer type, then we'll do the whole print error thing, and we should be good. Let's see. Expected pointer. Okay. So then we can actually do stuff with it, right? So the index is what we're gonna read, or it's what we're gonna write to. We need the size though. Well, no, we don't, because it's always gonna be 1. Well, no, it could be more than 1 byte. So depending on the data type, it's gonna be different. Right. Yeah, so we can actually switch on the data.type. And I'll just let's see. So what are all the data types here? It's kind of hard to, okay. Int type, float type, char type, pointer type, registered type. Why do we have a registered type? That's a bit weird to have. But we have it, so it is what it is, right? I think I should be able to copy this. That did not work at all. Oh, okay, let's see. So we have int type. Okay, base int type. Right. Base, I think I have float type. Right. Base pointer type. Right. Base register type. Right. And then what was the other one? Oh, I forgot char type as well. Char type and top type. I don't know what that means. I think that is like just a value for debug purposes data. Break. This should, yeah, I'm not sure that would mean that, but we need char type. Okay, so char type. Break. Okay, so, well, really, do I even need to do that? I could just have the amount that we write be that. So we need to write to the memory, right? So how do we, let's see, are we going to use probably memcopy, right? To just copy this amount into there. Yeah. So we'll do that. We need to, yeah, the amount is going to be based on the type. So we don't actually need this, but instead we could have an array for each of them. For now, I'm not going to do that though. So let's just, in typeset, actually, are they all going to be 8? Char is going to be 1. These are both going to be 8 though. Pointer will be 8 as well. And these, I think they are unreachable, so let me just, 0 and unreachable. Oh, wait, that's fine. Okay. So, we set the, let's do size t, amount equals 0, and we'll set here, amount equals 8, amount equals 8, because they're 64-bit. So, we can also just take these, put them right here, and yeah, use some follow-through stuff. Whoops, that did not work. And then, yeah, it's more concise. But again, I'll just probably replace it with an array and just use that as the index because that'd probably be easier. But this works as well. Okay, I'll find out about the register because I don't remember how that works exactly. Okay, but that's the amount that we're gonna write. So then we can then copy right into machine memory data plus the index, right? So that'll be the offset essentially. Is that what we want? No, but we need to get the plus pointer, because the pointer is the amount. It's not like, it's not really a pointer, it's really an index, but we can use it as the pointer. No, but it is actually a pointer. So no, that's not right. Hang on. Yeah, we want the pointer to really be the index. To treat it as, but no, we need it. We need the pointer, so that's not right. So how do we know stuff? We need to get the pointer, but how do we find the index in there from? Oh, we can just write to the pointer, right? Pointer. Yeah, I think that'll work. And then we want to write. No. So that's the dest, and then the source is data We need the pointer to the data. So, oh shoot, but we don't know what the data type is. We actually need to handle these differently. Data, can we just use data? Because the value is stored in there, but can't really do that. So we need to do that differently. But anyway, so I'm not. Yeah, so we need to switch on each type. So, I'm still going to leave this because I think that's useful. But we will do things a bit differently. So I'm going to just copy this, place it in here. Whoops, I actually need to go after this. Okay. So data dot as char, right? As int, as float, and as pointer. Okay. Amount. Okay, and that should write to it, right? Let's see if that compiles. It might not be right, but that's fine. Just learn it. Okay, statement may follow through. I think I must have missed something. Oh shoot. Okay, because I need oops, semicolon. I forgot that. What the heck? Okay, that's probably a problem. I inserted a lot of spaces. Here as well. Well, that's because I copied it. Okay, like that. Okay. Data has. Oh, okay. We need to do dot word. Yeah. Oh, I forgot. Because it is a data type, so we need pointer dot word dot as pointer. So yeah. Word. Word. Okay. All right. Now it compiles. So hopefully that's right. It might be wrong, but we'll test it soon, hopefully. Probably not today, actually, because I do have to go in about 20 minutes. I'll try to get it close, though. So then read, we're going to take the pointer, and we're going to read it to what? Then we're just going to push a pointer to it, actually. How does read work in here? So let's see. When we read, what do we do? We use at. I know there's the at symbol. Yeah, so balance at. So that we have the pointer to it. Okay, so that just gets the value stored at it. But we don't know what the type is going to be. So that makes it a bit more difficult, right? So we could have the pointer, it'll be on top of the stack, but to get the value stored at it, we need to know what the type is to know what amount we're going to read. And also what we're going to push, right? Because we want to push it onto the stack. So that is going to be a bit interesting. Trying to think. So what would be a good way to handle that? Okay. Yeah. Not sure. So, I mean, we could push the type onto the stack, like 0, 1, 2, 3, or 4, or whatever. Or we just push the amount to read, right? Actually, that's probably a better idea. So let's see, how do we do it here? Read. Yeah, so we need push the amount. So we have the pointer on the top of the stack in this case, right? Push the size to read. So say 8 if it's a pointer. And then just read that, and then we push the data that we read onto the stack. Okay. But how do we know? Yeah, we still don't know what the type is. That's the problem. Because we need to set the value based on the type. But you could cast it, I guess. But that might corrupt it actually. Okay, so what if we push the type, right? So you push 0, 1, 2, 3, or 4, whatever, right? So 0 would be int, 1 would be float, 2 would be char, 3 would be pointer. So we'll do that, at least for now. I consider better ways to do it. So yeah, we need to pop that. So it's going to be, this will be the size. Pop machine. If data if size type does not equal type int, then we just got to put air expected. There we go. Okay. Then what else do we have to pop? That's it actually. No, this is actually the type. Yeah, that's what it is. That's my bad. I forgot how we would do it. Alright, so type type. It still should be an int though. It's gonna be one of those. And then we just switch over. I got type. But we need to pop the pointer as well actually. So data pointer will pop machine. We have to check this as well, but for the pointer. Expected holding total. There we go. Yes. Should the pointer be an int actually? Now that I'm thinking about it. So it would be the index in the array, right? And that would probably work a lot better. And then, like, if we're doing stuff with it, we just take it, and then we get the pointer to the start of it. Yeah, okay. Well, I think I'm gonna change it. So let's do that instead. So we'll push it as int equals just basically the offset, right? Actually, just need the memory count minus that. Yeah, and we push it as an int type. Okay, and then a pointer. Yeah, so it's still pointer, but it's an int, right? If that makes any sense. Okay, and then we can do this, and instead, what is this? Why are we doing it like that? Data. So we'll have to write the data into it. But we need to machine memory data plus point dot as in. So that is sort of what we want here. Oops, that did not work. Memory data dot plus pointer dot as in. Okay. Okay. And the last one. Memory data plus pointer dot as in. Okay, yeah, and we still can work with it, the single points, and just take the pointer to the index if we need the pointer specifically. Okay, so then we pop it off, and it is an int. Yeah, and that's what we're going to use as the index to read from. So we can do this case, not over type, but type dot word dot as int. We will iterate over it, right? So case 0, we're going to do stuff. So that is type int. Case 1 is type float. Case 2 is type char. And then case 3 is type pointer. And Brecca is not a thing. Great, there we go. Okay, so what we're going to do is we're going to read from it. And the sizes are dependent on this. And also the output that we're going to do. So let's make a word data, right? So this is what we're going to write. It needs to be nothing to start of it. We need 0 initializer. Here we'll set data type equals type int. So you have to know what the type is when you are reading from it, but I think that's okay. It might change later though. So data.word.adds int equals we need to read from the memory. So how do we do that? We can memcopy again. Yeah, we just do basically the opposite, right? So memcopy into data.word.add int pointer to that. We take machine memory data plus pointer.add it. Just like that. And also the size is 8 with the pointer. Okay, I think that is pretty much it. Again, this is subject to change for sure. Okay, so type float is the same thing, but it's a float type, and as float. Type char is different. As char, because it is just one type. And type int is, let's type pointer, I mean, as pointer, and there we go. So save that, try to build it, and we have some issues. Word has no member named word, okay. Data, yeah, because data is a word, so we don't need a word. Data, okay, save that, go here, build it. Okay, we need to do .word for that though. Okay, there we go. Pointer.word.as in word, and we might have to do it up in the one above as well, because I might not have done it. So I will check that. Let's see, is this one the same thing? Yeah, it is. Okay. Pointer.word. Word, okay. Word, and the last one. Okay. Type pointer. Okay, it's pointer type, not type. Okay. Yeah, it's pointer type, not that. This as well. It's int type. 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 I'm not gonna change the comments because keep the same idea. Type and type. Type. That was weird. And pointer type. Okay, save that. And alright, so word has no member type. So yeah, we don't need to set that here. Actually, we need to when we push it. Primate's a word. Yeah, let's make it a data actually. We have to change some stuff, but that's okay. Dot words, we need to add dot word here. And then we can set the type. And that'd probably be better, because when we're pushing it, then we don't have to do it for each one, if that makes any sense. Okay, so data.type equals int type. Yeah, so I need to put this all back in, you know, I just got rid of it. Okay. This is pointer type and char type. Okay, and then we'll just push it, right? So we'll just push machine, and we want data.word and data.type. Okay, and that should be it. Okay, so it compiles. So now to test it, I would need to update the assembler. Okay, and I only have 10 more minutes left before I have to go. So I'm not sure that I'll be able to finish it, but I'll start on it. So let's add the keywords at least. So we can add those here. They have to go in the right place, I think, though. So first of all, we need to go into tagnexo.h and add it here. So it goes after this. So type memory, type right, and type read. Right. Okay, so that's how it's going to go. So it has to go after DRAM. That's fine. As a less messy. And the order is very important because it's used as an index. So that is why. DRAM. So right up here. Right there. Okay, let's add that. So we have memory, right, and read. Okay. So yeah, that should be pretty good then. Right there. Okay, and then I'm not sure. I think that's pretty much it for the Lexer. So now it's just gonna be different in the parser, and I don't remember exactly how the parser works. So it's gonna take a minute. Let me try to build it. All right, so it does still compile. So we should be able to Lex it. So we need to just check the type. So if the type, This is kind of nasty looking. And I'll probably go through and clean it up eventually. So we expect token. That's the number of tokens. What is this? Alright, so if it's any of those, okay, I guess we can just add it here. So if spec token, Lexer index. So that's the current index. Okay, and there's one, I guess. So type memory. So it's just the based on the arguments, I think. So we do index plus plus. Current token equals Lexer token static index. Just do plus plus index actually. Alright, I'm not sure why it adds all the spaces here. I'm gonna take a look into that. Okay, and then we check. So it has to be an int or a label after that. So in that case, that's okay. But for the memory, we don't want that. What do we want for the memory actually? So the whole thing. The memory, it should just have a single index. So we do have something else that needs just an int, right? So I think like what is it? Check if register. So there is a register type. So I'll need to look at how that's gonna work. But type moves, that's not it. Native. Actually, this is it. Yeah. So we could add it here as well. So let's just make this 3 and add type memory here. And then we don't need this whole separate one. I believe that should work. Okay, syntax, type of int. Okay. Yeah. And then we're good for that. So that is fine. But then for the read and write, let's start with read because it's a bit simpler. So we want a pointer. Well, first of all, we want the top to be an index, and the one under that to be a pointer. So, okay, but actually, in this case, oh shoot, so this isn't the same. This is using arguments, so that's a bit different. Yeah, so that's actually going to change stuff. So that's not how we want it. So we don't actually need this at all, because they don't have any arguments like that. Yeah, so we don't need this. I forgot. So this is for the ones that go after it. Right, so you would put like push 5, so like that. But we don't have those for these. We just use them without that. So I don't think we need to do that. I think it just appends it, right? Yo, what's up, Stam? How you doing? Token dev. So I think we're good then. Doing funny? How do you mean? Push string. Yeah, okay, so I guess if there's no argument, then we don't need to worry about that. And so it just gets added, right? With that. So I think we might be good on the parser. So now we just need to actually handle it in the actual tags.c, right? So how does this work? So we have all the instructions here. We need to add this here, okay. So after dref, so we'll put it right at start here. Inst memory. Inst okay. So if it's any of these, and we do that. How often I'm flashbang in front of my monitor. It's so funny. All the time, yeah. Shadow on the wall behind you. I do not have a wall directly behind me, so I don't have a shadow like that. It's a little ways away. Typical programming meme, yes. Actually, do we have to do anything for that? Flashbang, yes. That might be it. That is quite fun, quite fun. Light theme, haha, yes. Imagine using light theme though, for real. So is that it? I guess so, because this will set that. So I think that's it. So let me try to compile it. Build it. It does compile. Okay, so then let's try to compile the example. Anyways, don't have a wall too, but the shadow of your head. Oh, yes. Very fun. Text dot text. Expected non-type, but found late. Memory. Okay, so we have that. Right. Use bin. That's not bad. Read. Okay, so we need to get rid of these actually. So those are the only ones I would expect to work now. Alright, tire. It's not Tim. Seg fault. Alright, so that is cool. Let's try to perhaps modify the hasn't.c, right? No. Tin.c. Core dump, yes. Salute. Okay. Actually, I'm going to modify the tire.c and print stack. I want to print the stack of the machine. Let's see what it says. Oops. Okay. So let's actually build that and then run. Tire as content. I want to see. Okay, so we didn't actually output it. I am half stupid. Okay, change this. This isn't gonna execute because it segfault's in there, so I need to do that differently. Tim.c. I do need to do it in here, so let's do run. Yes, and then we'll just print the stack here. So each time we'll be able to see where exactly it is segfault. Yeah. Okay. As in, so we push the 8, and then it segfaults on the memory. So that is good. Well, I mean, it's not good, but you know. So we're not allocating enough, I suppose. So we know where it's at. It's what we're calling memory. So I should actually go here. I'm using Eve NG Linux. When I press Control, that I get stuck to run idle PC boot. I am not sure. I don't know what EVNG is. Yeah, I'm sorry, I don't know. And I don't know what idle PC router is either. So I don't know what those things are. I apologize. I'm not sure. It's in here. Probably from, well, no, what would it be? We're appending to it. But we're appending 0. Is that the issue? Let's try to, just print something there. Let's see how it works. See if it outputs that, you know? It does not seem to have done that. Yeah, oops. Okay, I actually have to go about now. So let me just see if I can get it to print test, and then I have to go, unfortunately. Okay. Test. So it did not execute that, but let me just make sure it did not save it, right? Okay. Make sure it saves. Do it again. Okay, so it's before that. That is interesting. We push 8 on, and then it failed. It doesn't get to this point. So it's, is this causing it? Let me put this in here. So, whoops, that's not what I wanted. Nope, nope. There we go. Like that. Okay, let's save that. And is it in that loop where it is failing? Seems to be. Okay. So calling DA append is not working. Why is that? Is this not right? Yeah, that's not it. Machine memory. Why does DA append not work? What is the issue with that? Let's exit out of this and let's open H. I really do have to go though. So I'm gonna look here just quickly. DA append. I don't know what the issue would be. Yeah, like data, and it's null by default. So count and capacity, so that's right. I do not know. Do we not zero initialize the machine, so then that's not set to 0 by default? That could be it. Let's see, when we load the machine, let's just set, let's set the data. So machine, memory, equals 0. Machine, memory, capacity equals 0. Alright, let's try that. Still segfaults, but just print anything this time. So segfaults even sooner, so that's not good. Okay, that makes it great more. Okay, I do have to go though, so I cannot continue looking into it. So I will probably commit this, even though it's in a broken state, but it's very early in development, so that's fine. Let's see, looking on implementing memory write and read instance. Okay, so I'll just put that, and then yeah, I do have to go. So thank you for watching, and I'll see you guys next time.